magnificence of the Colorado Rockies. Many have chosen to live along its Front Range, able to enjoy the beauty, climate, and recreational opportunities the area has to offer. They live in cities with familiar names like Colorado Springs, Denver, Boulder. And there's industry, developing and growing at times faster than the area itself. One such company is Storage Technology Corporation, located in Louisville, Colorado, midway between Denver and Boulder. Competing directly with the giant of the industry, IBM, Storage Technology has grown from a handful of employees in 1969 to over 7,000 and $500 million in revenues in just 10 years. This phenomenal growth can be attributed to STC's commitment to its customers to provide and maintain quality products to the computer marketplace. Today, STC is the world's largest manufacturer of high-performance tape storage systems and the largest independent manufacturer of disk storage systems. But the real story behind STC lies in its future. As part of STC's continuing philosophy of staying on the leading edge of computer technology, late in 1978, the Semiconductor Thin Film Division was formed in order to design, develop, and manufacture integrated circuits for use in STC's own products. Almost overnight, key people were brought in from all over the country to begin the monumental job of starting up the new division. Housed initially in a small building in Boulder, the staff grew from 6 to approximately 50 in the next few months. In December of 1979, the division moved from Boulder to its newly constructed semiconductor manufacturing facility at the Louisville site. The building has 55,000 square feet of manufacturing area and is equipped with one of the most advanced air filtration and chemical disposal systems available today. Currently, much of the work in the actual building of semiconductors is being done in the design area. At this time, various engineering groups are involved with the design of linear master slice circuits, read-write amplifiers, operational amplifiers, and thin film heads. This work can be seen in progress in our design area. Another aid used in the design of circuits is computer simulation. In this area, various portions of the design are simulated on a computer to check performance and worst-case behavior. Once the engineer arrives at a viable design, he draws a schematic. The engineer's schematic is then given to a layout designer, who then draws a composite of the circuit. The composite is drawn 500 times larger than the final size of the circuit for ease of drawing and digitizing. Once the composite has been finalized, it is sent to the computer-aided design area, where it is digitized. Here an operator is seen digitizing a portion of a large circuit. The composite drawings are made up of various coded layers that the digitizer must enter into the computer. Once digitized, a check plot is made to verify that the data has been digitized correctly. Once the plots have been thoroughly checked and any additional design changes made, the computer is used to check for design rule violations on the digitized data. When it is agreed upon that the circuit is correct, the digitizer makes a computer tape to run the pattern generator. The tape is written so that each level of the composite is a separate file. Here we see the pattern generator. This machine takes the information off the tape and translates it into aperture openings that are exposed on a photographic plate. When this is done, the plate is chemically processed and will be identical to the data on the computer for that particular layer, but at a reduced size. This process is repeated until all the layers are in reticle form. Once all the layers have been inspected, they will be sent to the photochemical area. The photochemical area is one of the areas in our manufacturing process that is not yet fully operational. Seen here is the equipment being set up and installed. When it is up and running, the DSW will expose the light source through the reticles and simultaneously reduce the image by 10 times, making an array of patterns on the silicone wafer. After the first reticle is exposed on the wafer is then sent to the wafer fabrication area. Here, depending on the layer, various chemical processes are used to actually build the integrated circuit. After the first layer processing is completed, the wafer is then sent back to the photochemical area to have the second layer exposed on. Once complete, the wafer is returned to the wafer fabrication area for another chemical process. The photochemical wafer fabrication loop is repeated until all layers have been exposed on and processed. Once this is done, the integrated circuit is complete. The area you're now seeing is what will be the wafer fabrication area. This is the diffusion furnace room. This will be the Silox reactor room. And here is the EPI reactor being installed and tested. This is the ion implanter room. Again, all of this equipment is used to perform the various chemical processes needed to fabricate an integrated circuit. Although still under construction, this area should be operational by the first quarter of 1980. Once the wafer is complete, the various die are tested. Here a technician is seen probing a wafer. Once tested, the bad die are marked. The wafer is then cut apart and the good die are separated out and sent to assembly. In the assembly area, the die are mounted in packages. Each is bonded to the package and sealed. Here we see an operator mounting a die in a package, and this operator is bonding a die to a package. Once the parts are finished, they are sent to final test, where they are subjected to a variety of tests to make sure they perform properly. Finally, the finished product is sent to Components Division to be used in the equipment it was designed for. As you've seen, there is still a great deal of work to do to get this facility into full operation. And in order to monitor progress in the various areas, upper management staff meetings are held frequently. Here the goals and schedules are set for the division. At this time, our highest priority goal is to be producing finished parts by the end of the second quarter of 1980. To meet this ambitious schedule, it will be necessary to hire approximately 150 more people in the coming months. Technicians, electrical engineers, mechanical engineers, layout designers, programmers, assemblers, test engineers, wafer fab operators. In short, all the people needed to run a semiconductor facility, a state-of-the-art facility that is part of a growing dynamic company called Storage Technology Corporation. It's a tremendous challenge, and if you feel you want to help us meet that challenge, give us a call. Maybe your future should be a part of STC's future.